is plus FB is MBA. This is for me. I rewrite this one because it's a bit maybe not very clear. So if I put this one here, MAG sine theta minus T plus FA is MAA. Then here also you could assume those discussion we had NA, and then MA cosine theta, these two can balance each other, and here also NB and MB cosine theta. So for here you could say NB minus MBG cosine theta, and here MA minus MAG cosine theta. So this Pulley's role is just changing the direction, but sometimes this can be a bit the same example that we had before, that you had inclined plane, you had mass A connected to B, but let's say this one B is connected to a pulley here, which is attached to a wall, for example, of the here, and then this is moving and connecting to mass C in this direction. So this rope basically just changing the direction of the force. So one thing here is that if the motion direction is in this direction, that means it goes down, then this mass C is going up because the tension of the rope wants to pull this up. So if I consider C as the system, you do have a force of, you could say, gravitational force as before, mcg cosine theta and mcg sine theta. These are the gravitational force corresponding to mass C. But there is a frictional force between these against the motion. So the motion is up, therefore the friction is down in this direction. And this frictional force is F B to C between the two objects. And T is the driving force for C. So if C is the system, then T minus F B to C plus MC G sine theta is MCA. That becomes the force. And there is a N B to C. So N B to C minus MC G cosine theta, this force and this force cancel each other. And we know that F B to C is mu N B to C. So these are the equation of motion, and the same T is applying to B, but then because B has a mass, when it's part of this will be consumed to control B, the rest it would be the force between A and B, which is the force between the other, in the other side of the mass B, and there is another tension. So we can draw this again, and considering, for example, this is B, Okay, I have to become very good drawing, painting, very much like professional paint. So, and this one is C, yeah. Now I want to consider B as the system. So this one is T, now it's resistive force. And then this is direction of motion, so it wants to come toward the direction of motion is for B is down, so C wants to stop it. Therefore, the frictional force between the B and C this time is in this direction. So this one is F C to B, which is the same as F B to C, but opposite direction. Action and reaction. Third law of Newtonian Mechanics. And then you do have the MBG cosine theta and MBG sine theta, and then there is a T prime. And T prime is the driving force now for object B. So we could say B is the system. There is a frictional force also here. This goes down, so there is another friction, which is FB. And there is N, B. And also the mass of the object B we drive here. There is a mass of C also, which is MCG cosine theta. That one is acting, pressing the C on top of B. So that being said, considering B is the system, is T prime driving force minus, here is T plus FB plus FC to B, two frictional force stopping B from top and from bottom. They both want to stop B. And but the MGB sine theta is the driving force basically. So I would need to add this to T. That means I need to add MBG sine theta. This is when B is the system. So there are two driving forces here, MBG sine theta and T prime. And this becomes MBA. I write it again. MBG sine theta plus T prime minus T plus FB plus FC to B is MBA. The acceleration is the same because they're all connected together and moving together. And also NB minus MBG cosine theta plus MCG cosine theta is equal to 0. And the relation FP and FCP is the same as the previous example. So FP is mu NB and FC to B is mu N C to B. So there is a basically pressing force here, which is mg cosine theta acting on here, and that will define the frictional force between C and B, and you have it here basically. So these two frictional force can be calculated. This is frictional force from the bottom surface here, and connected, related to the normal to the surface, and then there is another frictional force which is C to B, FC to B, and this is connected, related to this MCG cosine theta, which is here. So these two frictional force can be calculated, and when you add to the equation of motion, you can measure, calculate the acceleration, for example.